In this video, we are going to look at algebraic operations with vectors. Now, in order to do this, we're first going to need to learn how to express vectors in an algebraic way. And there are two main forms to do this in. Let's say we have a vector that starts from the origin and goes to the point 1, 2. And let's call this vector A. The first form is component form. And the way we can write vector A in component form is like this. And pretty much the top number corresponds to the x direction and the bottom, the y direction. So in this example, we have a translation of 1 unit to the right in the x direction and 2 units up in the y direction. So we can say that vector A in component form is equal to 1, 2, where this top number tells us the translation in the x direction and this bottom number the translation in the y direction. Now, the other form is unit vector form. And the way we can write this vector A in unit vector form is like this. And what I and j are unit vectors, which means their magnitude is equal to 1. And I in component form is 1, 0, and j in component form is 0, 1. And what this tells us is pretty much I tells us the translation in the x direction, and j tells us the translation in the y direction. So, based off this, vector A in unit vector form, or in unit vector form, would be 1i, or simply I, plus 2j. Now, how do we look at the magnitude of a vector? Well, the magnitude of a vector, or oftentimes in the context of vectors, is the length. And looking at this diagram over here once again, we can see that the length of this vector can be found using Pythagorean theorem. So the way we denote the magnitude of a vector is by using absolute value. So the magnitude of vector A is absolute value of A. And based off this diagram, we can calculate its magnitude, or its length. And this would simply be square root 2 squared plus 1 squared, or simply root 5. So the magnitude of vector A is root 5. And pretty much this is how it's going to be for every vector, not just A. You can simply use Pythagorean theorem. So if we were to have, let's say, vector B, which is in component form, let's say 4, 2, well, the magnitude of vector B would be square root 4 squared plus 2 squared, which is 20, or root 20, or you can also write it as 2 root 5. Now, what are some other algebraic operations we need to learn for these vectors? Well, let's look at how we can add and subtract these vectors. And it's actually very simple. The way we can look at the addition of vectors in this algebraic way is, let's say we have A and B in component vector form. A would be x1, y1, and B x2, y2. And here, vector A plus vector B is, you can simply just add the x values and the y values. So this would be x1 plus x2 and y1 plus y2. So if, let's say, vector A was 1, 2, and vector B were 2, 3, vector A plus vector B would be 1 plus 2 and 2 plus 3, or simply 3, 5. And similarly, for subtraction, vector A minus vector B, if we're going by this definition here for A and B, would be x1 minus x2 and y1 minus y2. So if these were the values for vector A and vector B, we would have 1 minus 2 and 2 minus 3, which is equal to -1, -1. And when you have negative, that just means you're translating to the left for if you're looking at in terms of x, and you're translating downwards if you're looking at y. Now, how do we multiply a vector by a scalar? Well, if we were to have, let's say, vector a, which is equal to x1, y1, if you want to multiply a by a scalar that is k, this would be, well, first we can multiply like this, and simply you can actually just multiply k in to each term. So this would be k x1, k y1. And simply, if we were to say vector a is equal to 1, 2, then vector a multiplied by some scalar k would be 1k and 2k. And if, let's say, k was 2, then this would be 2, 4. Now, let's combine what we learned. Let's say we want to find the magnitude of vector a minus 2 times vector b. And let's define vector a as 1, 2, and vector b as, let's say, 2, 1. Well, first, let's look at what's inside the absolute value. We have, if let's say, since it's already in component form, we write this in component form, it would be 1, 2 minus 2 times 2, 1. Now, the first step is to multiply the scalar into vector b, and this would give us 1, 2 minus 4, 2. And now we can simply subtract the vectors by subtracting the x value by the other x value, and same for the y. So this would be absolute value of -3 and 0, because 2 minus 2 is 0. And now we can just go ahead and use Pythagorean theorem to find its magnitude, which would be square root -3 squared plus 0 squared, which is simply equal to root 9, or 3. So the absolute value of a minus 2b is equal to 3. Now, what if we were to look at it look at vectors in space? Well, that would mean that there are now 3 values for, so if going back to component form, instead of just x, y, we now have z, which is another axis. And same for ij, or unit vector form, we would have xi plus yj plus zk. And k is the unit vector corresponding to the z-axis, which is 0, 0, 1. And looking at this from a perspective, if we look at it on an axis, Well, let's say this is the x-axis, this is the y-axis, and this is the z-axis. And it's actually pretty simple. If we were to have, let's say, vector A is 1, 2, 3. What this means is, well, we know the top number corresponds to the x translation. So this tells us we have 1 here. And this is the y translation. So we have 2 here. And this is the z translation. So we have 3 here. And now this means our corresponding vector would be something like this. And from the origin, it will go to here, like that. So pretty much this vector here, A, is translated 1 unit in the x direction, 2 units up in the y direction, or 2 units in the y direction, 3 units in the z direction. And going back to the operations with vectors, it's actually the same in 3D as 2D. So if we were to say vector A is x1, y1, z1, and let's say we had vector B, which was x2, y2, and z2, vector A plus vector B would be x1 plus x2, y1 plus y2, and z1 plus z2, which is pretty much the same as when we were working with 2D and just x and y. And similarly, in if we were to have A minus B, and let's look at it in unit vector form this time, this would be equal to x1 plus x2, or instead of like doing subtraction, it will be x1 minus x2 I plus x or y1 minus y2 j, and plus z1 minus z2 k. So pretty much it's the same. And once again, if you're doing scalar multiplication, so let's say k a is, you multiply it into all three, k into all three, so be k x1, k y1, k z1. And if you want to find the magnitude of a vector in space, well, you just use the Pythagorean theorem for 3D, which is square root x1 squared plus y1 squared plus z1 squared. And that is how you find the magnitude.